Hi, I'm Reed Johnson, and I did my science communication project on community infrastructure to increase resilience in the wildland-urban interface. First, some key terms to define. Environmental researcher Richard Hinberg defines resilience as, quote, the ability to withstand hard times or shocks. The U.S. Forest Service defines the wildland-urban interface, or WUI, as the area where human development borders or intermingles with forests or other wildlands. Defensible space is the area around the home or structure, which is field treated and maintained at a variety of distances. Heat transfer is the exchange of thermal energy through heat, classified in 3 heat transfer mechanisms: convection, conduction, and radiation. The wildland-urban interface model for defensible space is split in between 2 zones. Zone 1 is the first 30 feet from the structure. It should have no flammable fuels. And Zone 2 is the next 70 feet from the home or structure. Here, fuel should be field treated. The chimney, if present, should be thoroughly clean, and the exterior of the structure should be sealed and made from non-combustible materials. The wildland-urban interface model for defensible space deficit. It is limited in tightly packed neighborhoods with limited fuel mitigation capabilities. Case study from the University of Cincinnati. The Tubbs Fire was ignited in October of 2017 in Northwest California, outside of Santa Rosa. It was one of 4 fires burning in Central California at the time, and combined, they became known as the Northern California firestorm, as the fire displayed extreme fire behavior, being pushed by wind gusts up to 50 miles an hour. The Tubbs Fire alone was responsible for 22 deaths and over 5,000 structures lost. Many of the structures were in the wildland-urban interface and were in tightly packed neighborhoods. Resilient community infrastructure models, earth sheltering and vertical. First, earth sheltering models are protective against wildfires, as limited surface area of the structure is exposed and non-combustible or fuel-treated material is on and around the structure. This model is also defensible against tornadoes, storms, and earthquakes. Earth sheltering structures would only be exposed to the heat transfer of conduction, which is the weakest of the 3 heat transfer mechanisms. Conduction, it is the transfer of heat from more energetic to less energetic particles. In this earth structure example on the left, conduction would be the transfer of energy from the fire to the soil. Next, the vertical model condenses structures and populations vertically to allow for wildland-urban interface defensible space to be implemented around the vertical infrastructure to protect against wildfire. This model also allows for more open spaces and room for activities. Across the western U.S., the average number of fires over 1,000 acres or large fires has tripled between the 1970s and 2010s. In 2018, the U.S. lost more than 25,000 structures, and over 18,000 of these being residences. Tightly packed neighborhoods in the wildland-urban interface have limited opportunity for defensible space around the structure. To increase resilience, wildland-urban interface community members and planners must be concerned with the increased number of large fires and intelligently plan for the safety and longevity of closely packed communities in the wildland-urban interface, and look into fire-resilient community infrastructure models. These are my citations, and these are the pictures citations. Thank you.